Today we are going to see the indeterminate forms of the limits. Indeterminate form means the form of the number is in the form 0 by 0. After substituting limit, we get sometimes 0 by 0 form, infinity by infinity form, 0 into infinity, infinity minus infinity, 0 power 0, 1 power infinity, infinity power 0. These forms are called indeterminate forms. Indeterminate forms. These are divided into four types. For the purpose of solving the problems, these indeterminate forms are divided into four types. In the first form, 0 by 0. Second form, infinity by infinity. In the third form, 0 into infinity or infinity minus infinity. In the fourth form, 0 power 0, 1 power infinity, infinity power 0. So there is common way to solve these problems. Just a small logic only variation to solve this kind of any form of the indeterminate forms. So in the third case, for example, 0 into infinity, infinity minus infinity. These always converted into either first form or second form. After converting only, we substitute the limit values. If you know first form and second form, how to solve, obviously we can get third form. In the fourth form, we have some step. Whenever you see this form of the limit, you take the given function as a y value, y equal to given function. This is the logic. We will see later one by one. So first we will start the problems based on 0 by 0 form. First set of problems 0 by 0 form. These are the problems 0 by 0 form. First we pick the first problem. Here I provide the set of problems. So 0 by 0 form, 3 problems are here I am providing. Infinity by infinity, 3 problems. Third model, 2 problems. Fourth model, 3 problems. In this video lecture, we complete all these problems. Nearly 3 plus 2, 5, 5 plus 3, 8, 8 plus 3, 11. 11 problems are there. Now, first problem. First problem means 0 by 0 model. 0 by 0 model. So just you remember the concept 0 by 0 model. 0 by 0 model. Model 1 or type 1 or case 1. Type 1. 0 by 0 model. First problem. Whenever you see the 0 by 0 model, there is a procedure 0 by 0 and second model also. These two models, whenever you see, we apply the same procedure. Limit x tends to, for example, x tends to a, f of x by g of x. Function is always in the rational form. Substitute the x value, x tends to a in the numerator, we get either 0, denominator also 0, or numerator infinity, denominator infinity. In this case, this limit value 0 by 0 is not defined. Infinity by infinity is not defined. Why it is not defined means in mathematics, every number has a unique value. So 0 into 0 is written, some people written in the form 0 into 1 by 0. Some people think 0 into anything equal to 0. 0 by 0 equal to 0 into 1 by 0. 1 by 0 value is infinity. Some people says infinity into anything equal to infinity. That means 0 by 0 has two values. By using this property, we get 0. 0 by 0 has, by using this property, we get infinity. But these two are different. Every number has a unique in the real line. Therefore, 0 by 0 is a indeterminate form. Similarly, other infinity by infinity, 0 power 0, 1 power infinity, all things are indeterminate forms. In similar manner, because they have ambiguity. Ambiguity means more than one value is exist. So whenever you see this kind of 0 by 0 or infinity by infinity after substituting limit, then the limit value f of x by g of x value is limit x tends to a, differentiate the numerator and differentiate the denominator and substitute the limit. If this is also 0 by 0 or infinity by infinity, if we get, then take one more derivative. If it is a non-zero, stop here. It is a, sorry, it is not equal to, for example, this value not equal to 0 by 0 or infinity by infinity. That means it is a some defined value. That time we stop here only. Suppose this value is also 0 by 0 or infinity by infinity. This first derivative value is also 0 by 0 or infinity by infinity. This time you take this limit value f of x by g of x limit value equal to f dash x by g dash x limit value. This value equal to same procedure. You think f dash x equal to f of x, g dash equal to g of x. You take derivative. Derivative means already we have one derivative. We get second derivative. F double dash x by g double dash x, g double dash x, g double dash x. If this is not equal to 0 by 0 or infinity by infinity, stop here only. Whatever the value we exist, this value nothing but limit value. If this is also 0 by 0 or infinity by infinity form, take one more derivative. This is the approach to find the limit of the indeterminate forms. First problem. Problem 1. Problem 1. Which model? 0 by 0 model. In our set, first problem is problem 1. Evaluate limit x tends to 0 x into e power x minus log of 1 plus x by x square. This is the first problem in our list. In the typed list, first problem. This is the limit x tends to 0 x into e power x minus log of 1 plus x by x square. Now we want to evaluate this limit. Limit sometimes written as LIT, LT. Some people written LT, LT tends to x tends to 0, or some people write LIM, x tends to 0. Both are same. In I typed LT, but here I enter LIM. Both are same. Don't bother about it. Now substitute the limit value. Take given function, give limit x tends to 0 x into e power x minus log of 1 plus x by x square. Substitute x value in the numerator and denominator. 0 into e power 0 minus log of 1 plus 0 by 0 square. You observe that 0 e power 0 is means 1. 0 into 1 minus log 1 by 0, which is equal to 0 into 1 means 0. 0 into finite value. 1 is a finite value. 0 into finite value is 0. 0 into infinite value, we indeterminate form. So 0 minus log 1 value is 0. 0 minus 0 is 0 in the numerator. Total we have 0 by 0. 0 by 0 is indeterminate form. This is indeterminate form. So we apply the L'Hospital rule. L'Hospital rule means take a derivative of the numerator, derivative of the denominator. Therefore, by apply L'Hospital rule. Otherwise, don't bother about it. Simply you write down the answer. Limit x tends to 0, x into e power x minus log of 1 plus x by x square value equal to limit x tends to 0, numerator derivative, x into e power x, this derivative, UV rule, first function into derivative of second function, plus derivative of first function 1, derivative second function, UV rule, first function into derivative of second function plus derivative of first function into second function, minus derivative of log of 1 plus x is 1 by 1 plus x. Derivative of denominator function is 2 power x. Now once again you substitute this x values here. We get 0 into e power 0 plus 1 into e power 0 minus 1 plus 1 by 0 by 2 into 0. So totally we get, what about this value? 0 into 1, 0. 1 into 1, 1 minus 1 by 1, 1 by 2 into 0, 0. Finally, we get 0 by 0, indeterminate form. This is also indeterminate form. Indeterminate form. So apply one more derivative. Therefore, limit x tends to 0, x into e power x minus log of 1 plus x by x square value equal to first derivative also 0 by 0 form. So x into e power x value, first derivative becomes x into e power x plus e power x minus 1 by 1 plus x by 2x. This is also 0 by 0 form. So we take derivative one more time, numerator and denominator, and substitute the limit. X into e power x value is x into e power x plus e power x. E power x derivative value is e power x. 1 by 1 plus x value is minus 1 by 1 plus x square. Minus into minus plus. Denominator derivative value is 2 into x means 2 into 1. Now substitute x value. 0 into e power 0 plus e power 0 plus e power 0 plus 1 by 1 plus 0 whole square by 2. 0 into e power 0 means 0 into 1. 0. If you have any confusion, write down 1 plus 1 plus 1 by 2. This value is 0. 0 plus 1 plus 1 plus 1. Numerator has 3 ones. 3 by 2. This is the first problem answer. Next, second problem. Second problem is some more tricky because x power x is there. We also get 0 by 0 form, but anyhow, you alert whenever you solve the second problem or whenever they ask the second problem in the examination also, because exponential function is involved. X power x. Second problem. Limit x tends to 1, not 0. Here limit x tends to 1. Substitute x value by 1. Numerator function is x power x minus x by denominator function is x minus 1 plus log x. Log x plus log x. Plus log x. So here, if you substitute x tends to 1, I start here only, answer also 1 power 1 minus 1 by 1 minus 1 plus log 1. What about the numerator? 1 power 1 means 1. 1 minus 1 by 1 minus 1. These two cancel. Log 1 means 0. 0 by 0, indeterminate form. So we apply the L'Hospital rule. By applying L'Hospital rule, because the limit is indeterminate form. This is indeterminate form. By applying L'Hospital rule, limit x tends to 1, x power x minus x by x minus 1 plus log x. What about derivative of x power x? Numerator derivative means x power x derivative minus x derivative. X derivative is 1. No problem. Dx by dx equal to 1. So what about derivative of x power x? So whenever required the derivative of exponential functions, you always remember that take a function equal to y. Let y equal to x power x. No need to find, just you remember how to evaluate exponential limit. Then first step is let y equal to exponential function. Apply the limit, not limit, log on both sides. Log y equal to log of x power x. That implies log y equal to x into log x. Now we apply the derivative. Apply the derivative on both sides. 1 by y into dy equal to, apply the derivative here. First function into derivative of second function plus derivative of first function into second function. This is the limit value. That implies what about derivative of y? Dy equal to y times of xx get cancelled. 1 plus log x. What about y value? We choose y value is, or we assume that y value is x power x. So substitute y value. Y value is x power x. We start from y value onwards. So let x equal y equal to let y power x. That means derivative value y nothing but x power x. That means derivative of x power x value is this one, x power x into log of 1 plus x. Okay. Here we substitute. It is better to substitute in the next line. Limit x tends to 1. By applying LHospital rule means apply the derivative. X power x derivative is x power x times of 1 plus log x. Minus derivative of x means 1. The denominator derivative of x means 1. Derivative of 1 means 0. Plus derivative of log x means 1 by x. Once again substitute the limit value. X tends to 1. 1 power 1. 1 plus log 1 minus 1 by 1 minus 0 plus 1 by 1. Once again we get 0 by 0 form. No, 1 into 1 plus 0 minus 1 by 1 plus 1. 1 minus 0, 1 plus 1 by 1 means 1. 1 plus 1 total 2 in the denominator. What about numerator? Numerator value is 1 plus 0 means 1. 1 into 1 means 1. 1 minus 1 by 2. That implies 0 by 2. 0 by 2, it is not a 0 by 0 form. 0 by finite value. That implies this value is 0. Therefore, this limit value is 0. This is the second problem. Next, third problem. Third problem. So, third is very complex problem. It takes some time. You practice 1 or 2 times, then only we get the proper answer. By seeing it is easy. Mathematics always easy by seeing. By the practice only, we get the exact value. Problem 3. Important problem. Important means some complex problem. Find a value and b value by evaluating the integral. Find a value and b value such that I read on properly. Please find a and b such that limit x tends to 0, x times of a plus b cos x minus c into sin x by x power 5 equal to 1. Already they provide the limit value also 1. They want to values of A and B. This is the problem. Third problem. Okay. Answer. First substitute the x tends to 0 value in the left hand side. What happened? 0 into a plus b into cos 0 minus c into sin 0 by 0 power 5 equal to 1. 0 into something equal to 0. This term 0. Sin 0, 0. 0 into something equal to 0. Numerator 0 minus 0. Denominator 0 equal to 1. That implies 0 by 0 equal to 1. This is impossible because 1 is finite value. 0 by 0 is not a finite value. Indeterminate form means not a finite value, not defined. Not only, not a infinite also. Indeterminate form. Indeterminate form means neither finite nor infinite values. We don't know whether they, after simplification, they may get either finite value, they may get infinite value, but any one of them. But until we solve this or simplify this expression, we can't tell the either the resultant value is finite or infinite. So it is impossible. Impossible. You understand that in the left hand side we get 0 by 0. That means as per rule we apply the L'Hospital rule. We apply the L'Hospital rule. In the left hand side. By applying the L'Hospital rule, what happened in the left hand side? Thus the given limit value equal to UV rule, first function into derivative of this, or derivative of first function into derivative of second function, first function into derivative of second function. A value 0, b into cos x value is minus sin x. So in the right hand side 0 minus b into sin x plus derivative of first function. Derivative of first function means x derivative is 1. 1 into second value you take as it is, a plus b cos x minus derivative of sin x. C is constant. C does not affect in the factor product. C into cos x by derivative of denominator becomes 5 into x power 4, which is equal to 1. After simplification, we get a 1. As per given hypothesis, you understand that by applying L'Hospital rules, 0 by, if it is a 0 by 0 form or infinity by infinity form, by applying continuously L'Hospital rule, finally we get one answer. That is the meaning. But choose a comma b. Now substitute once again 0. X value tends to 0. 0 into minus b into sin x. 0 minus something equal to same value, plus 1 times of a plus b cos 0 minus c into cos 0 by 5 into 0 power 4 equal to 1. Take a cross multiplication. 1 means 1, 1 by 1. Take a cross multiplication. We get minus b cos sin 0 here. Otherwise 0 into something equal to 0. No need to write down first term. First term is 0. 0 into something equal to 0. 1. In the second term, we left with in the numerator a plus b. Cos 0 means 1. A plus b into 1 means a plus b. Minus c into cos 0 means c. C into 1 means c. By the cross multiplication, 0, 1 into 0. 1 into same, this value equal to same value. By cross multiplication, we get this expression. But here we have 3 variables, a, b, c. We required at least 3 equations to solve this. So once again, we apply the L'Hospital rule for the existing expression. So once again, apply the L'Hospital rule. That means you find the second derivative. This limit value equal to, here we have first Iradan simplified expression, b into x sin x plus a plus b cos x minus c cos x by 5 into x power 4 equal to 1. So apply one more time L'Hospital rule, because we can't get A, B, C values. If you know at least 3 equations, then only we get the A, B, C value. Otherwise, if you have any dependent variable, at least we required A comma B as a some relation or B comma C as a some relation. That time it is a 2 variable, 2 equations enough. Now, if these 3 are independent variable, we require 3 equations. If any 2 are dependent, one depend on another, that time we have 2 independent variable, that time 2 equations are required. Then you take one more derivative, it is better to get the value, more chances. Minus b times of first function into derivative of second function means cos x, plus first function into derivative of first function into second function means sin x, plus a derivative 0, cos derivative is minus sin x. So this value becomes minus b sin x, cos derivative is minus sin x, c times of sin x in the numerator, denominator 5 into 4, 20 x cube. Already 5 is there. The derivative of x power 4 means 4 into x cube. 5 into 4, 20. So this is the present value. Now substitute x value. We get minus b times of 0 into cos 0 plus sin 0 plus minus b. Here we get sin 0 plus c into sin 0 by 20 into 0 cube equal to 1. 20 cube into 0 equal to minus 1. Okay, anyhow. What about the simplification expression value? See, minus b, 0 into something 0, this is 0, this total value 0. Here sin 0, 0, this value 0, this value 0, numerator 0, denominator 0, 0 by 0 is impossible. So you take one more derivative, fourth derivative, using third derivative, using this derivative, because it is impossible. That implies 0 by 0 equal to 1. So up one more time, apply the L'Hospital rule. One more time, apply the L'Hospital rule. So limit x tends to 0. Apply the L'Hospital rule, we get minus b times of cos x minus sin x, x into sin x, x into sin x, plus cos x. So cos x derivative becomes, sin x derivative becomes cos x minus b into cos x plus c times of cos x by 20 into 3, 60. 60 x square equal to 1. Now substitute the limit value. Now substitute the limit value. Substituting limit value, the numerator minus b times of cos 0 minus 0 into sin 0 plus cos 0 minus b into cos 0 plus c into cos 0 by 60 into 0 square equal to 1. Take a cross multiplication. If you have any confusion, first simplify the numerator. What about numerator? Cos 0, 1. Cos 0, 1. This value 0. 0 minus 1 plus 1 means plus 2. That means minus 2b. Here minus b into 1 plus c into 1 by 0 equal to 1. Take a cross multiplication. Here numerator becomes minus 3b plus c equal to 0. From this expression, B depends on C. That means 3B equal to C. So two equations enough because B and C are dependent variable. A, B, C, already we have one equation. Substitute this value. Where it is better. Substitute this value in this limit. You observe that the third derivative, it is not good. I think it is better to because the third derivative involves B's and C's, or at least you substitute in the last equation. It is better. Last derivative, this one. We get a B value. Substitute this relation. That means C value, substitute C value, here. What we get? Not here, the previous equation. It is better. Here, substituting in this limit, minus B already we have derivative equations. First derivative equation, this is the, I think, x into first derivative. Yes, 0 by 0 form. So we apply the L'Hospital rule. This is the first derivative equation. Give the equation number 1. If you say this is Roman letter, it is comfortable to us. If you substitute C equal to 3B, here we get A plus B minus 3B. That means A minus 2B. A minus 2B. From, if you have any confusion, from take 1. A plus B minus C equal to 0. Substituting C value here, we get A plus B minus 3B equal to 0. That implies A minus 3B equal to 0. That implies A equal to 3B. If you know B value, we can get A value. If you know C value, we get B value. Or if you know B value, we can get C value. So which one is better to choose? Limit. A is a disappear in which derivative? In this derivative. A is a disappear. Substituting here, minus B times of, don't substitute directly here, minus B times of, here C sin 0, minus 3B, minus B sin x, here sin x. After substitution limit, we get a 0. So we have some problem. Here, minus B, 1 minute, minus B cos x, this is 0, minus B cos x, minus B cos x, minus 3B cos x, plus C cos x, C value equal to plus 3B, 3B cos x by 6 into 0. Okay. So it is better to take one more derivative. I think no need to take a derivative. 1 minute. Okay, very simple. We forget the logic, that's why. The third equation means the which derivative 60 by x square. Last equation. The last equation. This is the last equation. Okay. See, you take this. How many cos x are there? 2 cos x are there. Minus x into sin x. Here minus b cos x is there. So you keep b cos x and this one side and consider these other two or other side. Please rearrange the equation in this model. Limit x tends to 0. We have b times of 2 cos x plus x into sin x minus b cos x plus c into sin x. C into sin x by 60x square equal to 1. You rearrange this equation. You take first term, this term, 2b cos x plus c sin x, one pair. You take other equations, this and this. We have a common factor b, x sin x minus cos x by 60x square equal to 1. Here you take a common factor, limit x tends to 0, cos x as a common factor, 2b plus c sin x plus c or minus c plus c. Here we have minus b. That means minus b, minus 2b, minus 2c. Here this time we get here minus as a common factor, minus. So minus 2b plus c into the last term, not a sign. Here we have cos. I entered here sin. Here we have cos x. Cos x. Cos x is a common factor, minus b times of x sin x minus cos x by 60x square equal to 1. Substitute c value. Now substitute c value. C value equal to 3b. Limit x tends to 0. Minus 2b plus 3b into cos x minus b times of x sin x minus cos x by 60 x square equal to 0. 60x square equal to 0. That implies limit x tends to 0. Minus 2b plus b means b cos x minus bx sin x minus into minus plus b cos x by 60x square equal to 0. We have two b cos x values. That implies limit x tends to 0. 2b cos x minus bx sin x by 60x square equal to, sorry, 1, not 0, 1. Now substitute the limit value. 2b cos 0 minus b into 0 into sin 0 by 60 0 square equal to 1. 60 0 square equal to 1. What happened here? 2b, here 0. So once again, is there any mistake? You observe that minus b cos x, not plus b. Minus b cos x, here minus x. We take it is a positive quantity, not minus. Here positive. That's why we get some mistake. Anyhow, 0 by 0 form. Just you remember, if you have any confusion, simply leave it. Just to derive the one more time. See, you don't spend too much time. I am erasing. Just take a derivative. You always think in the denominator, remove the x values. Otherwise, at least we have a limit value. If we have a limit x also, see, just take one more derivative, or take two derivatives. We get the b value easily. Otherwise, it takes too much time. For pairing the values, it is take too much time. That's why avoid the process. Just take one more time derivative. Here minus b times of derivative of cos x means minus sin x plus uv rule, first function into derivative of second function plus derivative of first function into second function. Derivative of cos x means minus sin x, it becomes plus b sin x. Derivative of cos x means minus c sin x by, in the denominator, 60 into 2 means 120 x equal to 1. Now substitute the limit value. If you see x tends to 0, we get 0 by 0. Once again, it is better to take one more derivative until we remove x in the denominator. It is better. Otherwise, you get some confusion. Minus b times of sin x derivative is cos x. Just you simply reduce the exponent in the denominator or a polynomial as a constant by taking consequent derivatives. X into or cos x derivative of first function into second function minus first function into x value plus first function into derivative of second function. Derivative of second function is minus sin x. So plus into minus minus cos x. Here we have b into cos x minus c into cos x by 120. Not 1200, 120 only. X derivative is 1. We are happy. Just substitute the value of 0. X tends to 0. Minus b times of minus 2 cos 0. Cos 0. This value 0. 0 into something. 0 minus sin 0 plus cos 0 plus b cos 0 minus c cos 0 by 120 equal to 1. What about the simplified value? That implies that equal to minus b times of minus 2 plus 1, this value 0, this value 1, plus b times of 1 minus c times of 1 by 120. Take a cross multiplication. We get 1 into 20 equal to 120. Now simplify this expression. Minus b times of plus 2 minus 2 0, this term 0. Here b minus c. C value is equal to 120, but b minus c value is 3b equal to 120 minus 2b equal to 120. That implies b equal to minus 60. Substitute b value in the first equation. Substitute b value. B a plus b minus c equal to 0. A plus b, c value is 3b equal to 0. That implies a minus 2b equal to 0. That implies a equal to 2b. Already b value is minus 60 minus 120. That's all. Just you practice the problem, we can get the answer. Maybe sign, maybe I got a different. Actually, plus 160 plus 120. Somewhere sign is missing. Don't bother about it. You practice in the same manner, we get the correct answer. So answer is, you see, a value 120, b value is 60, not minus. Somewhere I missing the sign. Okay.